Today's video is going to involve adding and subtracting rational expressions with common denominators. And so far in this video series, we have talked about the key features of rational expressions, which come from the parent function y equals 1 over x. And we have talked about how to graph these functions on a coordinate plane and also graphing them from a table of values. We have also talked about multiplying and dividing these types of functions. And now we are at the end where we will be doing the last operations of adding and subtracting these types of functions. So let's go ahead and jump right in with what you will be needing to do. Pause and write down these steps. When the denominators are the same, you will be adding the numerators together just like normal fractions. If you had something like 4 over 3 plus 7 over 3, keep the denominator the same, and 4 plus 7 is 11. We are doing that same skill. You are just going to have rational expressions this time. And once you do your addition, you are going to have to combine your like terms, basically, and then see if the numerator can now be factored. So let's take a look at one of these practice problems right here. Pause and write this one down. You will notice that the denominator is the same. It says x minus 5. Good job. You are ready to move on, just like if this said 4 over 3 plus 7 over 3. You are good to add your numerators together. Since they are expressions, you would be combining like terms, and there actually aren't any like terms in this situation, so you would just have x squared minus 10x plus 25. You might think you're done, but you have to factor and simplify if possible. And in a lot of the cases, these problems, you can factor and simplify them a bit more. Notice how the numerator just became x minus 5, x plus 5, a perfect square, trinomial is what this is called. And that denominator of x minus 5 is now going to allow you to simplify by canceling out the x minus 5. So that means the only thing you're left with is the x plus 5, which becomes your final answer. Since you have to identify domain restrictions, and from a previous lesson we've talked about that the moment you cancel out a binomial factor, that is creating a removable discontinuity, which is a value that is not included in the domain. So the solution, according to the zero product property, when you set x minus 5 equal to 0, you would add 5 to both sides and get positive 5. So that means 5 cannot be in the domain. And again, this just comes from one of the previous videos that talked about our removable discontinuities. Go ahead and practice one of these on your own, but here's a little bit of a hint since we didn't say this in the first problem. If you happen to be in a subtraction situation, like you are right here, you're going to want to take that negative sign and distribute it to the numerator first, and then just combine like terms as though it were an addition problem. So start doing that, pause the video, and it's basically like the previous problem. And let's see how you did. So you would distribute the negative sign, and you would get negative 2x squared minus x minus 7. Then you would combine like terms with the first numerator to get what you see down here with x squared plus x minus 20. Negative 2x squared plus 3x squared is 1x squared. Positive 2x minus x is positive x. And negative 13 minus 7 is negative 20. Now, your denominator stays the same. Factor the numerator and the denominator in this case because it is possible. And when you do that factoring correctly, you have the following expression, which will allow you to cancel out the x minus 4s. I am moving quickly through this because it is a skill that has been talked about in previous videos. So once again, if you need to look at the multiplying and dividing video simplifying part, which is the previous one, to understand what happened here, please do so. We have the removable discontinuity at positive 4. It's always the opposite number of what you see in the binomial. And then the x plus 1 means that negative 1 cannot be included in the domain. All right, this is actually going to be a 2-for-1 special here because what we have to do to now finish things up is the same procedure, but your denominators are not going to be the same. They're going to be unlike denominators. So it's going to be a little bit of work in the beginning, and then the problem is going to look like what we were just doing. So this is the last part of the lesson. Here we go. Let's say you are in this situation. Well, you will factor all of your denominators first. Please write this down. This is where things require a lot of organization. You're going to factor your denominators first, so that you know what the common factors are as you make a common denominator. Just to tie this into Algebra 1 stuff, if you have 4/3 and you're adding 7 over 2, or actually let's pick some larger numbers. If you're taking, we can go with 5, whatever. But maybe there's a 15 right here, and then, we want one that's going to have a couple factors. 5 over 12, and then 4 over, let's go with 16. Nah, it's too big. So what happens when you do these problems on the spot and you have this information? Let's just go with what's going to give me what I want. Maybe a 5, sure. So you need to have a common denominator here, and 12 is really 4 times 3, and 5 is just 5. You don't have the same factors right here. The first denominator is going to need a factor of 5, and the second denominator will need both a 4 and a 3. But whatever you do to the denominator, you have to also do to the numerator in order to proceed. Now, I'm not going to multiply all of this together. I just want you to take note of the fact that the original denominator said 12, which has 4 and 3 as its factors, or even 2 times 2 times 3. But the other denominator being a 5, it did not have the same factors. In order to do this procedure, you need both of your denominators to have the exact same factors. They don't have to be in the same order, but they have to be the same factors. So let's actually jump into an example now and see how to do all of that. Just clear the screen. All right, here we go. So here's your problem. Factor your denominators. Notice it says x squared minus 8x plus 16. You can factor that into x minus 4 times x minus 4. Here's what you need to now observe. The other expression only has an x minus 4 in the denominator. The first expression, after factoring it, now says x minus 4 and then another x minus 4. So that means the second expression needs a second copy of x minus 4 so that both expressions will have the same factors in the denominator. Please pause and rewind if you need to hear that again. Both expressions need to have the same denominator factors. And since the first expression had 2 copies of x minus 4, and the second expression only had 1 copy of x minus 4, we need to give the second expression another x minus 4. And whatever you do to the denominator, you have to do to the numerator. So we're going to multiply by x minus 4, and then we're going to also do that in the numerator. This is the critical part of this piece of the lesson. Pause and rewind if you need to hear it again, because the rest of this is all things that we have done in previous videos with previous skills. You are now going to continue by multiplying your numerator together so that you will be able to add and combine your like terms. When you multiply that numerator, you get x squared minus x minus 12. And just to rewrite things with a little more neatness, this is what you now have. Combine your like terms. Basically, your denominators now have the exact same factors of x minus 4. Your numerator right here has now been rewritten because you multiplied that entire fraction by x minus 4. And now you can combine your like terms, and the rest of the problem is like what we just did. These problems definitely can get busy. Do not be shy about writing out a lot of work and taking up a lot of space in the beginning, because organization is key. Take your numerators, Combine all your like terms, you get 3x squared minus 11 when all of that combining is done. And then you can just leave it as x minus 4 times x minus 4, or you could even multiply things back together and just get x squared minus 8x plus 16. That's fine if you do that as well. It really doesn't matter. But your domain restrictions would be x cannot be equal to positive 4 because that would make the denominator become 0. I know these problems can seem fairly involved, so once again, pause and rewind if you need another review. But here is another practice problem that we will just jump into instead. Once again, take a look at what you have in the denominator and factor all of the denominators so you can see your common factors. The first two expressions are already factored with an m minus 7 and an m plus 7. But the third expression is a difference of squares. So when you factor the difference of squares by just taking the square roots, you will have a pair of conjugates right there in the denominator. So now we can see all of the factors that are working into this problem. We have an m plus 7 and an m minus 7. That means every single piece of this expression needs to have the common denominator of all the factors. So m plus 7 and m minus 7 needs to be there. The first expression only says m minus 7, so it needs an m plus 7. And then the second expression needs the opposite, just an m minus 7. Now look at the work here, and again, pause and rewind if it becomes necessary. We now need to rewrite the two expressions as follows. The first piece has to get an m plus 7. So whatever you do to the denominator, you have to also do to the numerator. That's why you see the m plus 7's right there. The second expression needed an m minus 7 in order to have the same factors as that last term, or the last part of the expression. And then the final piece already had the two factors in the denominator that were needed, so nothing had to be done. This is a critical part of the problem to just pause and make sure you understand that all three of the expressions need to have the same denominator. And whatever factors you include, you have to also include in the numerator, just because it's the same rules of fractions that we're not going to get into too much with this video. The rest of this is now just multiplying things together and combining like terms. So we're going to take our numerators and distribute, and then we're going to combine the like terms together. So you're going to have this expression right here. Combining like terms, you're going to get a 9m and a minus 25. And then your denominator could be multiplied back together to give you an m squared minus 49, or you can leave it as m minus 7, m plus 7. Either way, you are not allowed to use positive or negative 7 because that would make the domain become 0. Now, we have done a few of these problems at this point, so definitely pause and rewind to see these two easier problems. The last one is going to be a very much test level challenging problem. It's the same procedure, but a lot of strong Algebra 1 skills are going to be needed. So I would recommend you start by factoring the denominator to see what your factors are, and then try to incorporate the same factors to the remaining expressions. But this one is extra challenging because the third expression also needs a factor. This problem might take up a little bit of space, so I strongly recommend that you use a good amount of paper and give this a fair shot. And I'll break it down for you in a moment. And here we go. So when you start by factoring that denominator, you're going to get this expression by doing slide and divide or whatever factoring procedure you're doing. Then you will now observe we have a 2b plus 3 and a b minus 1. And what makes this a little frustrating is you can now see there's also a b minus 5 factor. The first expression also had a 2b plus 3, so that's already taken care of. But this third expression does not have a b minus 1, so you're going to have to incorporate factors to all three of these expressions. Let's go ahead and set that up. This is the most tedious part of the problem, so I'm going to organize it for you as best as I can. The first expression does not have a b minus 1 nor a b minus 5. It does have a 2b plus 3. So it's going to need a b minus 5 and also a b minus 1. The middle expression only has b minus 5. So it's going to need a b minus 1 and a 2b plus 3. The last expression does not have a b minus 5, which was alone in the middle right there. So the third expression is going to need a b minus 5. And again, whatever factors you give the denominator, you have to give those same factors to the numerator. This might be a good point if you are not sure how to begin to consider pausing and see if you can set up the next step, which is going to be a lot of work written out, but see if you can just set it up. And here's what it would look like. So your first expression, the 4b in the numerator, is going to get both a b minus 1 and a b minus 5, multiplying it. Your second term, minus 6, is going to get the 2b plus 3, and then the b minus 1, multiplying it. And then your last expression, the 3 times b plus 6, is going to only get a b minus 5 next to it. And now all the denominators are the same with all three of those factors. Just think of it like this. This third expression did not have a b minus 5, so it's going to get one, and it's going to be the same denominator as the middle term once you get a b minus 1 and a 2b plus 3 with it. And then the first expression, the same idea. Your denominator is now the same for all three expressions, so you can just take your numerators and add them straight across. Please drop a comment if you need a little more explanation on that, but this is the basic idea. The rest of this is Algebra 1 organization. You're going to multiply your numerators together by doing a little bit of FOILing on your binomials. You will then use the distributive property on the terms in front. So the 4b would distribute, the negative 6 and the 3 would all distribute to give you this expression in black. And then combine all of your like terms. Your denominator is the three factors that you just got, which are remaining unchanged. So this is your final expression, and I don't think I wrote down the domain value, so I'll just do that on the spot right here. Your domain cannot be equal to a positive 1, a positive 5, and a negative 3 over 2. All right. Definitely a more challenging problem, but I would recommend that if this problem did not go your way, that you just jump back to one of the previous two examples where things are a little more straightforward. Thank you for watching. Please drop a comment if you have any questions, and I will see you next time.